Okay, so I'm doing the chapter 3 review. I'm going to work through it with y'all just like I've done the first 2 chapters. So we don't have much vocabulary in this section because we spent a lot of time doing graphical displays. So there's a few vocabulary words. If you notice, they're just mainly different kinds of graphical displays, charts that you can do to show relationships. So without further ado, let's get into problem number 1. An article about college loans reported the percentage of students who had defaulted on the college or on a student loan within 3 years of when they were scheduled to begin repayment. Information was given for public colleges, private nonprofit colleges, and for-profit colleges. They ask us for A, to construct a comparative bar chart that would allow you to compare loan status for the 3 types of colleges. So the first thing we would want to do here, since we're doing a comparative bar chart, that's what they tell us here, a comparative bar chart. There's different charts that you could do as far as comparative. The one I'm going to do is, hang on, come on, why isn't this working? Okay, so would allow you to compare the loan status for the 3 types of colleges. So I'm going to do it by college. So my bars will be based on the college. Okay, first thing, since we're doing the bar chart, we need to get are a set of axes. So let me insert a set of axes that we can use. Okay, there's that one. There's our vertical, and here's our horizontal axis. Okay, so like I said, I'm going to do this by type of college. Might help if I had a pen here. Type of college. I'm going to abbreviate these. For public college, I'm just going to say P. Private nonprofit, PNP. And for-profit, I'm going to say FP. Okay, so I need P, PNP, FP. And then we need to get a scale here. Now, notice that on the high end, we're at 0.953. On the low end, we're at 0.047. So we need to get a scale that pretty much goes from 0 to 1 for relative frequency. We need a scale that goes from 0 to 1. So let's see what we can do about that. Okay, I'm actually going to make my axis just a smidge taller. Okay, so now let's see. I'm just putting in my tick marks here. Okay. So what I'm actually going to do is when I write, I'm just going to count by 20ths. Sorry, not 20ths, fifths. What was I thinking? I'm counting by fifths. Okay, so this is don't forget we need axis label. This is relative frequency. And now we need to get our bars in there. So give me a second and let me get the bars in right quick. Okay, so I just got the boxes in there. This is not where they should be. That's what our job is to do. I just got the boxes in there. I set up my key here, my legend here. So now let's go through and put them to the height that they should be. So since I'm grouping by colleges, types of college, I should say, I'm going to use green to be good standing. So green over here is good standing. And red is in default, which if you're not keen on financial lingo, that means they can't pay. They cannot pay their student loans. So that's why I put it red. That's not really a good position to be in. You get people mad at you. They come take things that are yours. So anyways, so for public college, whoa. Hang on here. Okay, let's stretch him. He needs to go up to 0.92. So I'd say about right there. Okay, so that's the public college good standing. Public college in default, we're at about 0.7072. So I'd say about right there. Now let's go on to private nonprofit. We need to be at 0.953. So perhaps that's about right there. And default is 0.047. Then for-profit, good standing is 0.833, so significantly less. I'd say, oh, yeah, about right there. And then in default's 0.167. So, I'd say maybe about there. And that may be a little too high. Let's do something like that. Okay, so there's our comparative bar chart. So we can see that public colleges and private nonprofit colleges are pretty close to each other. And we forgot our title. So let's say our title is loan payment status. They're pretty close to each other. Then your for-profit, yeah, they're pretty good, but they have more that are in default. At least twice as many as the public colleges. So, okay, part B says the article states those who attended for-profit schools were more likely to default than those who attended public or private nonprofit schools. What aspects of the comparative bar chart supports this statement? Well, we kind of just talked about it. Without looking at B, we really answered the question already. We could say confidently that the in default bar is taller in the for-profit category than in either of the other two categories. Thus supporting the statement. Or you can even take it further, the statement that states, and then quote it. On several Unit 2 or Chapter 2 assignments, people didn't really want to quote the question. Now on the test, the question's right there, but when you're turning in homework that doesn't quote the situation, I don't know what you're talking about. I mean, I do, but I don't. So, yeah, make sure you put it in context to fully answer the question. Okay, so the in default bar is taller in the for-profit category than in either of the other two categories, thus supporting the statement that states, or I guess I can take out the that states, thus supporting the statement those who attended For-profit schools were more likely to default than those who attended public or private nonprofit. Okay, so there's that one. We did the chart and then we had to analyze the chart. Let's look at number 2. So in number 2, it says a sample of 800 students who identified themselves as Democrats were used in a survey. Investigators asked students about their parents' political party. Their responses are summarized in the following table. So a couple of things to note here. This 800 is our total. That's how many. If I added all these up, I would get 800. Now let's see what the question asks. The question asks us to construct a pie chart for these data. Summarize distinctive features of this chart. So it's not enough to just draw the chart. You have to summarize it. Okay, so since we're doing a pie chart, we need to figure out the percent for each of these, the number of degrees of our circle. So I'm going to go and insert a circle. To be our pie chart. But then we need to figure out how many degrees each wedge of the pie chart should be. So let's see here. That's what I want. So let's do that now. Okay. So 600 out of 800 is 0.75 times 360 degrees. That means this one needs to be 270 degrees. So essentially 3/4 of a circle. Independence. 150 out of 800. Let's see, what fraction is that? That would be 0.1875 times 360. So 67.5 degrees. And then that means the 50 is the rest. So remember, our circle is 360. So I'm just going to subtract the other two, because this gives me 22.5 degrees. Okay. So now I can go through and draw my categories. And there's that. Okay, so here's going to be Democrats. I'm going to try to make it as nice as I can. Okay, so there's Democrats. Now let's see. Independence, I need 67.5 degrees, which is really like 3/4 of this wedge here, of the remaining wedge. Now I don't like that one. Okay, that's going to be close enough. So this one's going to be our independent. Just trying to make it as nice and neat as possible. Okay, and then that means the remaining would be the Republicans. Okay, so there is the pie chart. So it's not perfect, but it's close enough. Now remember, when you do a pie chart, it's not enough to just stop there. We need to label what each piece is. So the green piece here, what did we say it was? It's our small one. It's Republicans. This piece means their parents are independents. And then this big old chunk is where their parents were Democrats. Oh, that doesn't look right. And you could even go, since we know the percentages, because we had to get the percentages, you could even go so far as listing them. So we know independent is 18.75%. Democrat, 75%. And then Republican would be 6.25%. Okay, now it says to summarize the distinctive features of the pie chart. So let's come over here and summarize what's going on. Well, what do we notice? Well, there's some distinctive features. Well, we said 75% is Democrats, so 75% of the students who identified themselves as Democrat had a mother. It says this is the mother's political identification, not the father's. Had a mother who was also a Democrat. While only 6.25% had a mother who was Republican. That's really what we can tell from this. I mean, that's what we can say about it. Okay. Number 3. They tell us that in birds, the muscles that pull the wing down and thus cause the actual flight are the large pectorals. In the article, Dimensional Relationships for Flying Animals, the author reports the following pectoral muscle weight in grams for birds of prey. A asks us to conduct a simile plot for these data. Okay. So for a simile plot, really the only shape we need as far as shapes go that I need to insert is a line. And then we want to title it. So what are these measures of? These are measures of, I don't want to title it in red. Let's use black. These are the pectoral muscle weights. Okay, now let's go through, find our minimum, and then also our maximum to see how we need to do this. So if I'm looking at the data, I see an 84, 73, 53. Looks like my minimum is a 36. Maximum, seeing 958. Okay, so I know my minimum, I know my maximum. Now I have to figure out, how do I want to break this up? How do I want to do the stems on here? Well, we have one that's almost 1,000, but we have one that's 36. So I don't want to use the tens place as a stem because I would have to go from 3 all the way to 95. So that wouldn't be smart. What we could do is use the hundreds place, the hundreds place. So our stem, we create our keys, I guess right here, stem. Our stem is going to be the hundreds place. Our leaf will be the ones. Now this is one version of the key. Another version of the key could look something like this. Key. One, then 15 equals 1, or sorry, 1 with the bar and then 51, that means 151. That's another way you could do the key. But however you pick, you need to make it known. That way people aren't guessing. Then we need to go and figure out, how are we going to deal with the decimals? You can truncate, you can round, it's totally up to you. It's how you want to deal with them. You just have to, again, make note of it. These are supposed to be quick and dirty. So however you want to do it is how you can do it. Now, for me, I'm going to truncate. So this 113.5, I'm going to put it as 113 and just be done with it. 113, 79.8, I'm going to say a 79. 84.2, I'm going to leave it 84. 73.8, I'm going to say a 73. 53.8, 53. I'm just going to truncate the decimals. So let me make a little note here. Note, I'm truncating the decimal. I'm not rounding, I'm truncating. I am chopping it off. Okay, now we can proceed. So my lowest is a 36, so I'm going to start with a 3. And then I need to go up to, no, I need to start with a 0. I need to start, remember, our hundreds. So I need to start with a 0 and then go up to 9. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so let's see here. As I do these, I'm going to cross them off. So for the zeros in the hundreds, meaning they're just 2-digit numbers. What's my lowest? My lowest is a 36. So I'm going to, remember, when we do these, we go least to greatest. So 36 will be my first one. Cross it off. What's the next one? Looks like a 48. So I'm going to say 48 here. Cross it off. And I'm going to keep going through this process until I get them all on there. This is a 53. Okay, so I've dealt with all the ones that are just basically have no hundreds. So now I'm going to look for the 100s. I have a 149, a 113. Okay, that's going to be my lowest, 113. So 113. And it's looking like a 149, maybe. Yeah, 149. So 1, and then the 49 is my leaf. Then looks like it's going to be 151. And then 194. So I've done all my ones. Now let's move on to the 2s. So 226, 223. So 223 is my lowest. Then 226, 270, and then 299. Okay, now I have to look and see, do I have any 3s? No. Do I have any 4s? Yes, I have a 476. So I'm going to put it there. Then I'm down to a 715. So go down to 7, put my 15, cross it out. And then 958. So I should have everything now on there. I've built my stem and leaf plot. Okay, let's see what B is going to ask. B asks us in a few sentences, describe the distribution of the pectoral muscle weights. Okay. So let's see, what do we notice? If we kind of look sideways at it, how is the shape of the data? It looks like we kind of do something like this. Ooh, boom. Not even that. I mean, it almost goes, we look at the shape, and then we plane out. What kind of skew is that? If you turn your head sideways, the tail would be on the right. So our data is right skewed, or you could, we also said that's called positively skewed. So let's put that here in a few sentences. This is a positively or we can say right skewed distribution with most weights under 200 grams. Why did I say 200? Because I have 10 weights under 200 and only 7 above it. So even though, yes, I could technically say most weights under 300, most of my weights are under 200 grams. But they extend almost to 1,000 grams. We're at 958. The highest values are extreme outliers. Okay, so there. Well, we needed only 2 sentences. Okay, so that's number 3. Number 4. So same article that we used in problem 3, but now they look at the wing areas in square centimeters of the gliding birds of prey. So they separate night hunters from day hunters. Now they ask us to do a comparative, which is a back-to-back Simile plot for the wing area of the 2 types of birds. Okay. So let's see here. Let's first get our title set up. So wing area. I don't want to write in red. Wing area gliding birds of prey. Okay, there's our title. Now, if we look at our data here, we see some that go as high as 3715. Others are as low as, let's see, I think 405 is our lowest. So if I just did it by the thousands, my dot plot's not going to be much. So let's put day over here. Draw our line here for the comparison. And let's put night. Because if you look, for day hunters, for night hunters, we're gonna have 2 with no thousands, 3 in the thousands, and 1 in the 3,000. Day hunters, we're going to have 1, 2, 3, 4, 5, 6 in the no thousands, 2 in the 1,000s. That's not going to give us a good sense of the distribution. So we need to break these into high and low. So no thousand low, no thousand high. 1,000 low, 1,000 high. 2,000 low, 2,000 high. 3,000 low, 3,000 high. Now we get to space our distribution out. And remember, we need our key. So the stem we're using is the thousands. The leaf is really the ones. We can't say hundreds because it's all of them. So the leaf is the ones, how many ones are left. Okay, so let's look at let's do the day hunters. Let's do night hunters first. What the heck? Okay, so night hunters, we have, now the low thousands, that's 400 and down. So we're gonna have our 400s for the low. We have 405 and we have 459. So 405, 459. Those two are done. Then we look at the low, or sorry, we have no highs with no thousands. The low 1,000s, that's gonna pretty much be almost the rest of them. So we've got a 082, a 1,163, 1,304, and 1,396. So we got all our thousands knocked out. And then for the 3,000, it's a high because it's 3715, 3,715. Now it's still not spread out a huge amount, but hey, it's better than what it would have been, especially when we take into account the day hunters. So day hunters, do I have any low no thousands, 0,000s? I have this 438. So 438. Then I go to the high. My lowest is a 530. So 530 is gone. I have a 558. I have a 703. A 708. And then an 822. Okay, and then do I have any low thousands? Yes, I have 2. 1,285 and 1,317. And then I have a 2,321, so that's a low 2,000. So 321. So these aren't, even then, these aren't spread out the greatest, but it still gives us an idea. I mean, this 400 would have been lumped in with the rest of the no thousands, and we wouldn't have seen, wait a minute, it's really the low, it is the low one that we can see plain as day. So it did help some. Still not a great data set, but it helped. It's as good as we could do. So there's our comparative dot plot. Now B says that biologists speculate that since birds could be detected at a distance by their prey during the day, on average, the species that hunt during the day should be smaller on average than those that hunt at night. Are the data displayed in part A consistent with this theory? Okay, so let's see, what's it saying? It's saying that the species that hunt during the day should be smaller on average. Okay, well, let's look. Come on, work with me. Those that hunt during the day should be smaller. Yeah, most of them are smaller. I have 6 of them that are really small. I mean, the majority of them are smaller than the majority of the night hunters. Now, I don't have as many observations for the night hunters, but I mean, my gosh, look. I could almost come in and draw a line here. And the majority of the day hunters, yeah, they would be smaller than the majority of the night hunters. So yes, it does support our statement. So let's talk about that in our answer here. We're going to talk about just exactly what we said. So yes, let's make this bold. Yes, the majority of day hunters are below 1,000 centimeters. I'll come back and fix that. Squared. While for night hunters, the majority are above 1,000 centimeters squared. Let me fix these. So yeah, it definitely supports that. This supports the statement on average, the statement that on average the species that hunt during the day should be smaller on average than those that hunt at night. Okay. So that is number 4. We had to do a comparative stem and leaf plot and then analyze it. So let's look at number 5. As part of the United States Census Bureau, data is collected on the number of persons in each household. The census data for 4 decades is summarized below. Okay, so let's look. What do we notice? So this is households by size. Okay, let's see what it asks. In a few sentences, describe how the proportion of households with 4 people has changed from 1970 to 2000. So the proportion of with 4 people. Okay, let's look at the ones that have 4 people. So 4 people are these kind of 10. Well, now I'm highlighting them in blue. So what do we notice? They're slowly decreasing, but they didn't decrease much. So let's say that. Now I don't want a text box there. I want it down here. Okay, come on. Work nice for me. Well, that's what we're going to say. The population of households with 4 people has decreased slightly from 15.8% in 1970 to 14.6% in 2000. That's really all that happened. It didn't decrease much. It just decreased slightly. Okay, so there's our answer for part A. That was pretty straightforward. Just can you read a graph? Part B, what size of household appears to have decreased the most from 1970 to 2000? Well, let's see. What percent did they change? So 1970 to 2000. That's what we're looking at here. So 1970 to 10.4. Let's just go through 5 people or more, 4 people or more, etc. So 10.4 minus 20.9. This is going to be down 10.5%. 14.6. So the new minus the old, minus 15.8. It's going to be minus 1.2. 17.3. Wrong way. 16.4 minus 17.3. It's going to be minus 0.9. 33.1 minus 28.9. So this one actually went up 4.2. And then 25.5 minus 17.1. This one went up 8.4. So I would say that the 5 people or more seem to have the biggest hit. If you look at the decrease, it went down 10%. It lost 10 percentage points. So that's what we can say. The largest households with 5 or more members decreased sharply from 20.9% in 1970 to 10.4% in 2000. This is a decrease of 10.5 percentage points. The other households either grew in size or only decreased slightly. I mean, we have a clear winner with 5 people or more. It's our clear winner here. So nothing fancy, nothing elegant, just enough to get the job done. Remember, like I've told y'all in the past, keep it as short but detailed as possible. You don't want to linger too much further, because then you can start getting yourself into trouble. The AP graders grade the weakest part of your answer. So state the facts, make your point, and move on. Okay, so for number 6, it says in the article, scaling of mammalian long bones, small and large mammals compared. The average circumferences, which remember circumference is the distance around something, in millimeters of the humerus, femur, and tibia of different species of animals were reported. These are the long bones that primarily support the body mass in mammals. Each data value is the mean circumference for the available measure for a single species. Okay, so if we look, it looks like they give us histograms here. So we have a count of frequency, basically. So one thing we want to look at is our scale. It appears the scale is the same on the x-axis, so this scale is the same for each one. Vertical axis is almost the same, but not quite. Okay, yeah, so let's see. A says describe the differences and similarities in these distributions of these different mammalian bones. Okay, so let's kind of look here. Let's look at the shape first. So on this one, we're definitely skewed right. Skewed right. Skewed right. Okay, so all 3 of them are skewed right. The tibia circumference doesn't spread out quite as far. Notice the top 2 have some that go either up to 300 or just past it. Tibia doesn't look like it goes past 250. So tibia is kind of a little bit tighter in. than the rest. But I mean, that's really just looking. That's about the only thing I could really see to describe. So let's just start there. Let's start there and say that. Okay. So the shape of the distributions the shapes of the distributions, I should say, are very similar, with a peak between 25 and 50, and they're all positively skewed. Which, remember, positively means right skewed. And then, as we mentioned, the humerus and femur circumferences extend closer to 300 millimeters as compared to the tibia, which stops just shy of 250 millimeters. Okay, so again, I mean, we talked about all of those. I mean, the peaks are in the same spot. We can see that based on the distribution. So we pretty much nailed it. Nailed it, governor. Okay, B. Biologists speculate that the different amounts of weight might be supported by different sized bones. Based on the histograms, does it seem like one of these bones has, on average, a greater or lesser circumference? Explain. Well, let's look at the graphs here. So they all pretty much have about the same shape. I mean, the differences aren't really that great, other than the femur and humerus tend to go out further as far as how spread out the values are, but they all tend to be kind of clustered in the same areas. I mean, that's maybe the larger animals have a larger humerus and femur because they support more of the weight. But I mean, yeah, there's not really much to say here. So let's just say what we can, and then go from there. So let's put a text box in here. Get it. Come on now, cooperate. No, There, thank you. Okay, let's see here. So let's just say what we just said. The differences are not great since the large parts of the distributions are very similar. Perhaps for the largest animals, the humerus and femur support more of the weight indicated by the fact that these distributions extend to higher values than does the tibia distribution. I mean, we're kind of limited. Our hands, it's almost like our hands are tied here because they are so similar. Shape outline, no outline. Okay. I mean, yeah. This one was kind of a tough one because they want you to compare them. There's, I mean, not really much to compare. They all look pretty similar. And then they want you to support this theory that they all look so similar. So again, we're kind of stuck between a rock and a hard place here. We did the best we could, so let's move on. 7, the following cumulative relative frequency graph displays the distribution of the lifetime in hours of a particular brand of AA battery. So we have this graph here, it's cumulative relative frequency. And then they ask us 3 questions about it. Okay, so this one is going to be more about reading a graph than anything. A asks us approximately what % of batteries will last fewer than 350 hours. Now remember, cumulative relative frequency means it's eventually going to sum to 1. So whatever our x is, that value is everything up to that x. So we want to go to the 350, trace it upwards, and then over to the axis. Let's do that. 350, trace it upwards. We hit there, then we go over. So I would say probably about 92 to 93% is what I would kind of dare to say. I mean, approximately what percent? It hits at about 0.92. So there's not really much to say other than about 92%. Because remember, 350 represents that relative frequency represents 350 and below. Okay, next one. Approximately what proportion of batteries will last 225 hours or more? So let's find 225 on the graph. Remember, this graph will tell us 225 or less. So less than 225 is going to be about 0.18. So that means we can say that that leaves us with 0.82 will last 225 or more. Okay, then C says 50% of batteries have lifetimes below approximately what value? So I got a 50%, that's going to be on my y-axis this time. I follow it over to my graph. Boom, I hit there, and then I go straight down. So that's going to be about 275. So we would just say about 275 hours. That's really all there was to this question. We're just reading a graph. That's it. It was that simple. Okay, number 8. Investigators studying the relation between gender and the interest of early adolescents asked boys and girls in grades 5 through 9 to indicate on a 7-point scale their degree of interest in topics such as life, sports, and cars. The data in the scatter plot represents average levels of interest for boys and girls in grades 5 through 9. Each point represents one topic listed by the investigators. For example, boys' average rating for the opposite sex is a 6.2, while girls on average rated their interest in this topic as 6.0 on the 7-point interest scale. So they recorded the point 6.2 and 6.0. Okay. And maybe this dot right here where my mouse is at. Okay, let's see. It says there are 3 interesting features in the scatter plot that you are to interpret below. What can you infer from each of these features of the scatter plot? A, the points generally seem to scatter around the line y equals x. Well, let's see. Let's draw that line on our plot. So I'll start at 1 here and then draw from one corner to the other. Okay, let's see. Yeah, they felt pretty close to it. So this line right here is the line y equals x. Okay. So what could this mean? If they fall pretty close to this line, what could this mean? That means that, well, think about it. So remember, it cut it off down here, but this bottom represents your boys or your males. Let me write that instead. This represents your male population. So if they're about as close as they are to this line, that means that boys and girls pretty much favor the same things. There's two that aren't, but for the most part, boys and girls rated them about the same. So let's comment on that down here. This means that the average interest for topics is about the same for boys and girls. And that's really what that means. B, there seem to be three clusters of points, one in the lower left, one in the middle, and one in the upper right of the graph. Okay, so let's focus on those clusters for a second. Let's see what those tell us. So here's one cluster. Here's two clusters. Here's three clusters. To me, what that kind of says is that they tend to rate things not only the same, but boys and girls tend to give some things higher, like that's most of their interest, while other things are not quite so much their interest. So they seem to agree on most areas of low interest, medium interest, and high interest. Except those two outliers, but we're getting to them. Patience. Patience, young one, patience. Let's comment on this feature. Boys, I'll need this bold. Boys and girls seem to agree on most areas of low interest, which is our lower left cluster, medium interest, which is the middle cluster, and high interest, which is the upper right cluster. I mean, that's really all it tells us, as they seem to agree on certain areas. And then C, there are 2 points as indicated by the arrows that do not seem to fit the overall pattern. What can be said about the topics these points represent? Well, what this says is that they tend to differ quite a bit. So in both cases, the males tend to rank them higher than the females. So these are 2 topics right here that males tend to rate significantly higher than females. I mean, we don't know what those topics are. Maybe one's vehicles, cars, the other one's fishing. I don't know. But evidently something's going on. So come on now, work for me, work for me. I need to type here. Okay. There we go. Now we're working. Let's put into words what we just said. So these points indicate that there are two topics for which the interest levels for boys and girls differ sharply. For both of these topics, boys indicated a higher interest than girls. Okay, so that's really all we had to do here. Now, one thing I want to point out on this problem, notice how I theorized what the topics could be in my head, but I never actually said it. I just stated the facts. There's two interests where they differ. In both cases, boys have a higher interest than girls. We don't know. Let's not theorize. Let's just leave it to pure statistical facts. Okay, so that's the review. Study it, know it. Ask me if you have questions, and good luck on the test.